Okay. Surface area of a triangular prism. A triangular prism has 2 triangles on the sides and then 3 rectangles. It has 5 sides. Yesterday we did a rectangular prism and how many? 6 sides. Okay, so here's the information I have given you. This side is 10, this base is 6, the height of the triangle is 4, and the 2 sides is 7 feet. This is an isosceles triangle. Okay, it's a rectangular prism because it's 3D. Alright, so we need to find the area of each of the sides in order to find the surface area. Okay, let's do the 2 triangles. Now, do you think the 2 triangles have the same area?
Yeah.
Yes. Okay, to find the area of a triangle, we do base times height divided by 2. Alright, plug in your numbers for the base and the height of your triangle. So what is the area of our triangle? 12 feet squared, and this one's 12 feet squared. Good. Now, how many rectangles do we have? 3. Do they all have the same measurement?
Yeah.
No.
No.
They do not.
Well, I think the sides have the same.
Well, there are 3 sides.
No, but like the left and right, like not the bottom one.
So, we have, let's look at the one in the back. This rectangle right here in the back. This one. Do you guys see the back one?
Yeah.
Okay. What is the measurement of the length? 10. And what's the length or width? 7. So one of the rectangles is 10 by 7, so therefore the area is 70. We don't divide by 2. Now, let's look at the triangle at the bottom that I'm going to put a bunch of dots on so you can see it. The rectangle that's at the bottom. Okay? So, the rectangle that has all the little dots inside. What are the measurements of the rectangle all the way at the bottom? 10 by 6. Because this is 6. So the area is Now I'm going to do the one on this side. The one you actually saw from the very beginning. So what is the measurement of the one that's all the way in the beginning? 10 and 7. So that's 70 feet squared. So 2 of the rectangles are equal because 2 of these sides are equal, right? So if you have an isosceles triangle, then 2 of the rectangles will have the same area. If you have an equilateral triangle, then all the sides, all the rectangles will be equal.
So it depends on the triangle?
Yes. If you had a, what do you call a triangle that has no equal sides?
Look around, guys.
No, it's not up yet. It's over there where it's naming triangles, I think.
What?
Naming.
Oh, yeah.
Yeah. You see right here where it thinks I'm not going to teach naming triangles? So, isosceles, equilateral, scalene.
Oh.
Scaling. Alright. So, let's add this up. Yeah. So surface area is 224 feet square. It's very similar to a rectangular prism. This one's a little bit harder because you're dealing with a triangle. But again, the math is not difficult. It's just a lot, and you just have to write it down. There's no other choice. All right, see if we can do this one. And I like to draw and highlight it in different colors so you can see the 3 different rectangles. Alright, let's see if you can draw even a better rectangular prism. Be a pro like Miss Lamelli. It's the only thing I can draw. you remember, make sure that your height is always made with the 90 degrees. Because kids sometimes think like, oh, this is the height, or this is the height. Remember, your height is always created with the 90 degrees. Unless you have a right triangular prism. Then this would be your height, your base, and then like a side. If you have a right triangular prism, then this is your height. Are you guys waiting for me?
No.
Oh. Do you have an answer?
Is that scaling triangle?
This is a scaling. No? What? What'd I do now?
What was wrong?
Yeah. 72.
Oh. Oh. Darn it. Just checking. Just want to make sure you were doing it correctly. Hopefully you weren't just copying me, because that's a no-no. 260. Good. Hmm? I know. When I'm putting these numbers, I'm like, that really doesn't create a triangle, but it's okay. It's okay. For this math lesson, we're just using the numbers. All right, are we okay with triangular prism?
Yeah.
So now, rectangular prism is in the books, triangular prism is in the books. Now, Jessica, what are we doing? Cylinder. All right. So, let's do it. Cylinder. What kind of shapes are in a cylinder?
Circle. Another circle. Oval. Wait, no.
Cylinder. So here's my water bottle, right? It has a circle on top and a circle on the bottom, right? But what shape is this part, this round part?
Round
Oh, I put away all my scissors. Hold on.
It's a big, long rectangle that connects.
It's a square circle. Oh, she's cutting it.
Okay. Okay. Ready to be amazed by my magician abilities. I'm just cutting off the label, guys. Relax. Okay. So this round part of the water bottle, which illustrates basically this part of the cylinder. Any label of a can, right? The label goes all the way around. And when I take it apart, the shape that it creates is a rectangle.
And they thought it was crazy.
Okay. So, what are the three shapes that are involved in a cylinder?
Circle, rectangle,
Yeah. So you have two circles, right? And you actually have a rectangle. So to find the surface area, you have to find the area of the top circle, the bottom circle, which are equal, and then a rectangle. Okay? You get that? So a lot of kids, they don't see this part. They're like, oh, it's a circle? I don't understand. Well, there is actually a rectangle involved. Okay? Alright? If I were to if this was like a sticker, around this cup, the original shape of the sticker would be a rectangle. That would go around this. Okay? Okay. So, let's do one with the map. I think that's it. Okay, so the area of a circle is pi r squared for the area. Okay, so we know it's 3.14 times, what's my radius? 6 squared. 36 times 3.14. What do we get? What's 3.14 times 36? Good. So that's the area of the circle. And this circle is equal to the bottom circle, right? So we can just add a second circle with the same area, right? Okay, so those are my two circles. Check. Now, we got to do the rectangle. Well, what measurement do we know of the rectangle? 15. Right? The height. Okay. So, we need to know this part, right? It was a circle. Okay, here's my circle. What does the 12 represent? The diameter, right? This part. So, oh look, it kind of is the size of my finger, right? Well, but when I open it up, oh, it's doubled? So, wait a minute. What I have this, what part of this?
Circumference.
This is the circumference of the circle, right? Do you guys see that this is the circumference of the circle? But when I open it up, it really is the width. Isn't that crazy?
No.
You have to find the circumference of the circle. The circumference of the circle actually is your width.
Wow.
But isn't it funny how everything's connected though?
Yeah.
Like, it's very interesting to me. It's like, oh, I need something that I learned before in order to apply it here. I need the